Okay, number one, so if light enters a medium that has higher refractive index, then it slows down and bends towards the normal. Okay, just for example. Okay, A, then water. Okay, now let's say we have an incident ray. Incident ray coming from A, entering water. Okay, your first job, draw the normal. Without the normal, you can't do anything. Draw the normal. So normal at this point, it has to be at the point of striking here. So the line of normal is perpendicular. Okay, like this. Now, does the ray go downward or upward, away or towards the normal? Then you have to look at the refractive index. Okay, what does it say? If the light enters a medium that has higher refractive index, so it will bend towards the normal. So what is the refractive index of A? So A is, if you look at your textbook, the table, there's a table of refractive index there. N is equals to 1.33. No, 1. I think just 1. The A is always 1. Refractive index of A is always 1. Okay, it's 1. 1.33是 water. Okay, so water, the refractive index is 1.33. Okay, now here you see the higher water has a higher refractive index, and thus it bends the light ray towards the normal. So how do you draw the refracted ray? The refracted ray, you draw it like this. It has to be close to the normal. Okay, so label, this is the I and this is the R. Okay, now second example. Okay, same medium, so A, and then water. Now, if the light ray is coming from the bottom, from water, this. Okay, so now the incident ray, this becomes the incident ray. This is the incident ray. Any light ray that is pointing to the surface, pointing to the boundary, is the incident ray. Okay, incident ray. So this incident ray, this normal. Now, where does the light ray enters? It enters A, right? From water to A. On top is from A to water. Okay, so this is from water to A. So meaning that it is entering a medium with a lower refractive index, because A is just 1. N equals to 1. And this is N equals to 1.33. So light ray is entering from 1.33 to 1. So lower refractive index, so it bends away. Okay, bends away like this. Okay, so this is the angle incident, angle of refraction. Lower refractive index, good job, and bends away. Now, okay, now for medium that is of higher refractive index, there is a name again. There's a name for it. A medium with higher refractive index, this one, we call it denser. Okay, a denser medium is a medium with higher refractive index. Ryan, focus. Okay, now a medium with lower refractive index, we call it rarer. Okay, it's another word for less dense. Okay, rarer medium, a denser and a rarer medium. Okay, now if you look at the first picture, this one, from A entering water, right? A is a rarer medium. Water is a denser medium because it has higher refractive index. Okay, so you can think of it like this. Whenever light ray enters a denser medium, it will move towards the normal. Okay, at the bottom, this one, air is rarer, water is denser. So the bottom one, the light ray enters a rarer medium. Okay, it is coming from a denser one. It enters a rarer medium, so it bends away. Okay, it bends away. Any question? Question? No question? Okay, take this down and yeah, erase that this one. Okay, now just a little bit more than just wrap up this today's lesson. Okay, now guys, next one we talk about the Snell's law. The Snell's law of refraction. Now again, same with reflection. There's a law governing it. For example, reflection. What is the law again? The law of reflection says that the I equals to R. Yeah, kind of like scientist, but I don't know his full name. Okay, so Snell's law. Okay, there's law of reflection, and there's also law of refraction. What is a law? The law is a theory. Okay, something that everybody follows. Okay, something that is being proven true. Okay, by thousands and thousands of experiments. Okay, so the Snell's law of refraction. What did he say? He says that when you have a medium, okay, light ray coming through here. Okay, let's take a particular scenario. A to water. A to water. Okay, so where does the light ray go? Towards the normal, because water is a denser compared to air. Water is denser medium. So yeah. So goes downward. Yeah. Light ray, light ray. Okay, so this is the I, and this is the R. Now Snell's law, it says that the refractive index and the refractive index. What is a refractive index? The strength of the material to slow down the light speed. Yes, the higher the refractive index, the higher the strength to slow it down. Okay. Now, the refractive index, Snell's law, he says that okay, this n is equals to, he gives this formula, sine I, and then over sine R. Sine I over sine R. This is what he says. Okay, but what is it? Sine I over sine R, meaning that if you take the incident angle, the sine of the incident angle, divided by the sine of the refracted angle, then it is the refractive index. Okay, that is the refractive index. And this is the same as the one that you calculated for n equals to CV. It is the same. So you should get the same value. If you take the light speed divided by the speed in the medium, the n, you should get the same as this one. Okay, it's the same. Now, let's say this is 40 angle, 40. And this is okay, here's an example here. second. Okay, let's take 30. Okay, the angle here is, the angle incident is 30, and then the angle of refraction is 20. Okay, given the angle of incident and the angle of refraction, calculate the refractive index. Okay, now again, this one you have to calculate refractive index, but the question didn't give you the speed. So you cannot use this formula. No, not this. You cannot use this formula because you don't have the speed. But you do have the angle, incident and refraction. So you take this formula, you calculate n equals to, yes? Yeah, from the calculator, that one. Okay, the trigo in mathematics, okay, sine. Okay, sine 30, and then you divide it by sine. Just put in the formula, okay? Just put in the formula. Sine 20. Sine 30 divided by sine 20. What is the answer? Anybody?
Teacher, so in the exam, the numbers will be given to you, right?
Yeah, the number will be given to you.
Oh, okay.
But sometimes, Giant, sometimes they will give you the n, and they give you only the incident. They ask you to find the refracted. 1.46. Okay, so 1.46. Okay, so 1.46. Okay, so this is the refractive of this one. So another one, if you have two medium again, M1, M2, incident and refracted. Okay, again, I draw the normal like this. Okay, this one same, the incident angle is 30, and then the refracted angle is, let's take 15. 15. Okay, again, calculate the refractive index of this medium. Okay, now the first one, this one is, the first medium is A. First medium is A, and second medium is whatever medium that is denser than A. Okay, so N equals, again, sine I, N equals to sine 30 over sine 15. What is this, Ryan? Can you calculate again? Sine 30 over sine 15. 1.93. Okay, now what do you see here? The first case 1.49. The second one 1.93. It's higher. The second refractive index is higher, right? It's higher. So what happens to the diagram? Look at the diagram. The first diagram, the angle of refraction after the bending, the angle become 20. Initially it's 30. Okay, if there's no bending, it should come out here as 30 also. But now there's bending, so it reduced down to 20, right? This is the angle of refraction. Now, if you compare with the second diagram, the second diagram is reduced down to 15. So the bending is greater, right? The bending is greater. There's a greater extent of bending here. So the refractive index, okay, my point is this. The refractive index, you see, higher refractive index, greater bending. Okay, higher refractive index, greater bending. So two things you need to remember. Higher refractive index. Okay, refractive index is a measure of, first, strength to reduce speed of light. Strength to bend the light. Okay, so two things. Refractive index is a measure of the strength of the material to reduce the speed. This one we talked about this before, just now earlier. And then it is also a measure of the strength to bend the light. If higher refractive index, then higher bending. So the angle of refraction will be smaller, even smaller here, this one. Okay? Because the refracted ray is closer to the normal ray, to the normal line. Okay, it's closer to the normal line. Now, again, bear in mind that this N is always what? The light always comes from free space. Light always enters from A. From A, only then you use this formula. Okay, this formula, light always comes from the A. Okay?
Light doesn't come from the dot.
Sorry?
Light
comes from the router. Now, let's say here I have let's say this is the glass. This is the glass block. The light ray comes from the bulb, strikes here, right? So if you don't look at the bulb, the light ray also comes from the air. Okay. The starting medium is the air. Okay. Finish already, right? This one. Okay, one example. Okay. What if one value is not given, like Giant asked just now? Okay, let's say sometimes it will give you like this. Okay. Initial ray. Normal. And then refracted. The incident angle is 30. And they say that, okay, this is A. Again, it must be from A. So from A, this is the incident ray. And this is the refracted ray. Okay. Now, let's say that this medium 2, is glass. And the refractive index of glass is 1.53. Then the question asks, calculate the angle of refraction. Okay, so the angle of refraction is not given, but it gives you the refractive index. Okay, so N equals to sine I over sine R. Now N is given, so 1.53 equals to sine 30 over sine R. Okay, now many students are not able to do this, solve this equation. So how do you solve this equation? This one, okay, this one is over, right? Sine 30 over sine R, right? This one you exchange places with this one. This one goes here, and this one goes down here, right? So you have sine R equals to sine 30, yes, sine 30 over 1.53. Yeah? So what is the value of this one? Right? Sine 30 over 1.53. Yeah, sine 30 over 1.53. 给我4个 4 decimal places. Okay, 0.3267. Right? This one divided by this one, you get this. So how do you find the R? The R, the angle R, you have to move the sine to the other side. Okay, so it becomes what? In your mathematics, you learn this. If you move the sine to the other side, then it becomes what? R is still at the left hand side. R is still at the left hand side. So here it becomes the sine. If you go to the opposite, it becomes sine -1. Okay. Times cross the negative becomes divide. Divide cross negative becomes time. Positive cross, times cross the equal sign becomes divide. Divide cross the equal sign becomes multiply. Positive cross the equal sign become negative. Sign cross the equal sign, you get sign -1. Okay, so sign -1, 0.3267. How do you find the sign -1? It's in your calculator. You have to press the shift. Okay, shift sign -1, 0.3267. What is the answer? What's the answer, Ryan? This one. 找到吗？ sin 减1。Where is the sign -1? It's just above the sign. Yeah, okay. Yeah, press it.
19.068.
Okay, so 19.07. That's the angle, final answer. Okay. Okay, anybody having problem calculating this one? Let me know. You cannot press the calculator or you can't find it. Okay, now last part before I give you exercises. Okay, you see a refraction that happens in everyday life. For example, let's take one scenario. Okay, this one is you have a pool of. Okay, let's take the swimming pool. Okay, let's say this is the swimming pool. Okay, this is a swimming pool, and you stand here. Okay, this is you. All right. Now, if you look down to a swimming pool, right? Sometimes you realize if you stand just beside the swimming pool, you look down, you'll see that the depth of the swimming pool, it seems shallower than it actually is, right? So why this happened? Because of refraction also. But how does it happen? Okay. Now here we're going to talk about this one. Okay. Now let's say this is the surface under the water, and this is the boundary of the water. This one. Okay. So you have two medium here. This is water. This is A. Okay. Now let's say you are looking at the bottom here, this X point. You are looking at here. Okay. So what happens to the light? The light ray, the first ray comes out straight up. This is the first ray. Okay, we need to draw at least minimum two rays. Minimum two rays. So this is the first ray, always straight up, come straight up. Okay, I use another color. The first ray always goes straight up like this. So the arrow like this. Again, if straight, so here is where the point it strikes the boundary, right? But it's straight, is perpendicular. This light is perpendicular to the surface, to the boundary. So what happens? Is there any change in speed? Yes. Is there any change in direction? No. All right. So there is change in speed. Does the speed speeds up or slow down? Because there's two medium, right? It enters from water to A. There's a change in medium. So there is a change in speed. Okay. So light speeds up here. Why? Because A is a rarer medium. Water is a denser, medium. Water is denser than air. Okay, water is denser than air. So you go from denser to less dense, the speed speeds up, and it bends away. But there's no bending in this case because this is straight perpendicular line. Now another ray goes like this. I use different color. Let's use black. Okay, another ray goes like this. Strikes this surface at an angle. Okay. Now if you draw the normal, this is the normal like this. Where is the angle of incidence? It is always the between the ray and the normal. Here, this is the eye. Okay. Now notice that this one, this ray, it strikes the surface at an angle. So what happens? There is a change in direction and also speed for refraction. Okay. So does the ray bends towards or away from the normal? From denser medium to rarer medium, it bends away, right? From denser to rarer, enters a rarer medium, it bends away from the normal. It bends away, so it's like this. Like this.
So the reason why we see it showing up is because it reflects our eye.
No, I haven't finished. Wait, almost. Okay, so this is the original path. This is the original path of the ray, the dotted one. The black ray is after the bending. It bends away like this. Now, if the position of your eye is here, okay, let's say I draw your position. This is your eye. Imagine this big. Okay, this is your eye. Okay, this is your eye. Now, it is receiving two rays. The first ray is the red ray. The second ray is the black ray. Right? This ray and also this ray. It is receiving these two rays. Okay, we need at least two rays. Okay. Now, these two rays, your eyes, it will find where is the source of these two rays. The red one and the black one. If you extend the black one, you extend it here, dotted here, 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 until here, you will find that they will meet at the same point here, the X. Okay, the black ray, if you extend here, they will meet with the red ray at this point. Okay, let's name this point. This is point I. Okay, point I. Okay, so the light ray, your eye, it will automatically find where is the source of these two light. So the source of these two light is when they meet. But is it actually true? We don't know. That is just the perception of your eye. Okay, what your eye perceives is not actually true, right? It's just what you see. Okay, the light ray can trick you. Okay, so it will find where is the source of this light. So it's extend. It is at this eye point here. So eye point, you see that this distance, it is a distance away from the bottom, right? It is a distance away. This one we call it the height, the height difference here. There's a difference here. Okay, or we call it the rays. This is the rays. Okay, so what do you see? You see that the flow is actually at this level rather than the bottom. This level, you see this level. Okay, you see this level. So that is why the depth of the swimming pool appears shallower than it actually is. Okay, because of the light refraction. So it tricks your eye. So it sees that this is the distance of the bottom of the swimming pool. Here, it's over here. This straight line here. Okay, so there's a difference in the distance between the bottom and here. Okay, so this is we call it, this is the apparent depth. This is the apparent depth from surface to this black line. From the surface until the bottom is the actual depth. Apparent depth, what it appears to your eye, and also the real depth, the actual depth. Okay, so if you're looking into the water, any surface that you're looking at a coin or anything, still it will appear raised because of the bending of light, because of the refraction. Okay, Now, you can actually draw like this here. Okay, I think you can copy down this one lah in your book lah. Just take this down in your book. Draw this diagram.
But this only happens sometimes, right? If you stare at the wrong point, then you see the actual depth of the
Wrong spot. What do you mean wrong spot?
你讲如果你看到那个 line 那边
哦，你在哪里你都会看到这样的，因为这个 because this ray out not only these two 嘛 there's millions of light rays like this. So not only your position is here, your eye not necessarily here, then you can see. No, you stand here also you can see. Okay, I draw the eye like this because I want to let you see the light ray that enters the eye like this. Okay, actually there are millions and millions of light rays. This is I just take two. Okay, so you stand here, you still see the bottom is raised. Okay, if you have finished, you do the revision 2, page 184. 184 revision 2, all of revision 2.
this physical conditions like very changes in the electronic system. Yeah. Yeah.